Okay, so I asked you to do 13 to 16 on this sheet that we've been working on. So number 13 is a 196 Newton, 0.2 Newton box, so I'm giving you Fg is 196.2 newtons, is being pulled across the floor with an 88 Newton force acting upward at an angle. So F here is 88 newtons. This is Fx. This is Fy. This will be Fn. Acting backward will be friction. Upward at an angle of 36.87 degrees. The coefficient of friction is 0.244, and it wants to know what is the acceleration. Okay, so in the x direction it'll be cosine to get your component. So cos theta is equal to Fx over F. So Fx is equal to F cos theta. Okay, and you could find this if you wanted to. I don't know that I would, but 88 newtons cos of 36.87, 0.864. So 70.4 maybe? 70.4, yeah. 70.4 newtons. It's really 3,999, but I'm rounding to 4. And then this sine theta will be equal to Fy over F. So Fy will be equal to F sine theta. And if you didn't want to stop with these, then you would do Fy is equal to 88 newtons sine of 36.87, 0.648, 52.8, I think. Yeah. 52.8 newtons. All right, so you have your Fx, you have your Fy. So now we're going to go and do some of the forces in the y direction. It should be equal to MAY. This thing is not moving in the y direction, so it'll be Fn plus Fy, because it's going up, minus Fg is going down. So Fn will be equal to Fg minus Fy. Fg is just mg, and Fy is F sine theta. Oh, I didn't have to write that because they told me the n. So it's 196.2 newtons, and it's minus 52.8 newtons. So Fn is equal to 143.4 newtons. So I have my Fn. While I'm here, I could find friction. If you want, it's mu Fn, or you could just go to some of the forces in the x direction and do it in there. So in the x direction, there's Fx minus friction is equal to Max. Fx is F cos theta, which we already found, and friction is mu Fn, which we can find shortly. We're solving for A, so divide by M. So Ax is equal to 70.4 newtons minus 0.244 times this 143.4 newtons. And then divide it by mass. And we can get our mass by doing Fg equals mg. So m is equal to Fg over g. So 196.2 newtons divided by 9.81 meters per second squared gives us a mass of 20 kilograms. So 20 kilograms goes here. And when you do this math, you should get 1.771 meters per second squared. That is part A. Part B says if the box starts from rest, VI is 0. How far will it have moved, delta D, in 6 seconds, delta T? So you know delta D is equal to VI delta T, 1/2 A delta T squared. Starts from rest, so the VI is 0. So 1/2 1.771 meters per second squared by 6 seconds squared. 6 squared is 36. Take half of it is 18. 18 times 1.771 is 31.87, if I can believe the answers on the sheet. Meters. Okay, number 13. Number 14. A 30-kilogram box is being pushed across the floor. So this is 30 kgs. And it's being pushed across the floor, which means it's going to be going downward with a force of 200 newtons. And it's downward at an angle of 30 degrees. This will be Fx, this will be Fy, Fn, friction, Fg. Accelerates at a rate, Ax, of 1.8 meters per second squared. What is the coefficient? Okay, so again, you can do your Fx. It's going to be the adjacent sign, so cos theta equals Fx over F. So Fx equals 200 newtons cos of 30. Fx equals cos of 30 is 0.866 times 200 should be 173.21 newtons. Fy is sine, so sine theta equals Fy over F. So Fy is 200 newtons sine of 30, and it gives us Fy to be 100 newtons. All right, then we go to sum of the forces. So sum of the forces in the y direction, this object is not moving in the y. Fn is going up, Fg is going down, Fy is going down. Always solving for Fn, so it'll be equal to Fg plus Fy. So Fn is equal to mg plus F sine theta. So 30 kilograms times 9.81 meters per second squared plus 100 newtons. Fn is equal to, I just need to store that so I don't lose it, 30 times 9.81 is 294.3, so 394.3 newtons. And now we go to the x direction. Is equal to max. We have Fx minus friction is equal to max. Fx is really F cos theta, which we know already, minus mu Fn is equal to max. And this time we're solving for mu. So take this term over, bring this term over. So F cos theta minus max equals mu Fn, and now divide by Fn. And fill our numbers in. So mu is equal to 173.21 newtons minus 30 kilograms times 1.8 meters per second squared divided by 394.3 newtons. On the top, 3 times that is 724, 54, and then divide by, and I'm cheating and looking at the answer, 0.3023. 0.3023. Okay, so that is number 14. Number 15. We might need to start a new video for number 15 because we're about to run out of time. Box being pulled across the floor, 300 newtons at an angle of 53.13 degrees. Fg is acting down, Fn is acting up, friction is acting backward, coefficient is